All right, so this is chapter 2. There's a lot of stuff in this chapter. A lot of the basic building blocks are going to be here in this chapter, and so this is kind of starting from scratch here. So there's a lot to go over, and also try to keep in mind as we're going through these things. We're kind of building up our skill set, I guess you can say. In fact, throughout the whole semester, we'll be kind of building up our skill set, and the more things that we learn about, the more interesting and complex problems we can address and come up with solutions to. All right, so try to keep that in mind, especially in this chapter as we're talking about all these individual little things. Here at towards the end of the chapter, hopefully today and towards the end of class, we can take all these things and write our first example program together. Okay, so that's kind of my goal. Hopefully we'll have time to get through it all. All right, so let's just start here at the beginning, and some things I might go through quicker than other things, and also I believe that there's even more examples in the book, so you definitely need to be reading over the chapters in the book. Like in chapter 2, they'll have more specific examples and little example programs, maybe throughout the chapters. So you need to be doing both. Okay. So this chapter is the basic elements of C++. We're going to be starting from the beginning. So we'll talk about some things like, basically a C++ program is a collection of functions. Here at the beginning, we're just going to have one function. But anyway, we'll talk about these basic building blocks and basic ideas like what are special symbols, what are identifiers, what are the rules for identifier names, what are data types, how is that affected, or how is that related to memory, how much memory things get reserved for in the computer. Then we'll get into arithmetic operators, and we'll do a little bit of basic math. And the goal of the math part is not necessarily to test to see whether or not you learn how to do elementary school math or anything like that. It's more about how does the computer actually process and do these calculations. Okay, and so those arithmetic expressions. We'll talk a little bit about the string type in this chapter, not a lot, but a little bit. Assignment statements, and also some basic input and output, how to do basic input and output using cin and cout and C++. Increment and decrement operators are here. Also, there's, I think, remind me to not leave out the compound operators. And also a little bit about things like preprocessor directives, like header files that you have to include, why those are important. Right. How to do comments in C++ also. So we'll talk about all those things. All right. So basically, a computer program, I think I may have mentioned this last week, is the sequence of statements that solves a problem that so it accomplishes some kind of task. And so programming is the process of planning and creating a program and implementing that program in a programming language. Here we're doing C++. The real world analogy is like it's maybe something like writing and following a recipe for cooking. So here at the beginning, Malik actually shows you an example of a complete C++ program. And so we're going to be working towards this, but notice a few things here. We've got this thing, you see the word main, and open and close curly brackets. So all this is going to be the main function, all that stuff. Up here, these statements here declare some variables. So it reserves memory for these things. And double is a data type. So we'll talk about data types here in a minute. Cout is going to output this information or this message to the screen. These statements here do some calculations, where we maybe assign some values and then do some calculations down here, and then these cout statements down here just output some results to the screen, basically. And then we'll talk about the return 0 later. And this stuff at the top, these are comments that basically explain what this program is all about. And then up here at the top, this is the header file that we have to include in order to do basic C in and C out, input and output. So, anyway, so that's the chapter. I'll see you guys later. No, just kidding. That's an overview of where we're going to end up. Okay. All right, and that would be like a sample run of that program. Right. So here they're just showing, hey, basically these are all the things I just pointed out in that slide a minute ago. All right. Yeah, let's keep going. All right, so a few quick definitions here. A subprogram or a function is what we call it in C++. Is a collection of statements that are related that accomplish something, basically. And all your programs in this course, you're always going to have at least one function, and that's the main function. The name of it is main. And then later on in the semester, we're going to learn how we can write other functions. We can kind of separate our program into different modules or different pieces, and each one of those pieces is like a self-contained module of code, and each one is what we call a function here in C++. If you hear the words like syntax, what does syntax mean? That just basically means the rules of the language. Are you following the rules of the language? Is it valid or legal? So just like natural languages like English or Spanish or French or whatever have grammatical rules that you're supposed to follow, in order to be correct in the language. Programming languages also have those, and so that's a big part of what we're going to be doing this semester is just learning those rules for C++. Semantic rules, if you hear that just means the meaning of the instruction. And so a programming language is you can kind of describe it in some ways as a set of rules, symbols, and special words. First thing here, the first little skill that we're going to learn is how to write comments. So comments are instructions in your source code that are there to, usually there to document what something is doing, what this code is about, right? And so comments don't get executed by the computer. It's not going to do anything, but it's there for like someone who's reading your code. They can read the comments and see, oh, okay, this is what this does, and this is what this is about, and so forth. Because sometimes you might be working in a group to develop a program, or it could be you write a program and then maybe you leave the company or whatever, and someone else has to come along and take your code, or you end up with someone else's code that's already been written, and you have to figure out what's going on. Well, comments are there to help explain stuff. There's two main ways to do comments in C++, and this is true of a lot of other languages too. If you can do a comment by doing 2 forward slashes, so if you put 2 forward slashes in a row, then the rest of the line from that point on is a comment, and so it won't get done. It won't get executed, but it'll make that a comment. That's called a single line comment. So you could do it like this. If you had multiple lines, you could put 2 forward slashes in front of each thing. Okay. The other way to do a comment is a multi-line or block comment, sometimes I'll call them. And the way that you do that is you put a forward slash and an asterisk at the beginning of the comment, and then you put an asterisk and a forward slash to mark the end of the comment. And then everything that's in between those two things becomes a comment. Right? So like here, they just put that at the beginning and that at the end, and everything in between was a comment. And sometimes what I'll do is, I'll do that, but then I'll add some asterisks, kind of like they did up here, just to make it look, a little bit prettier or whatever. But anyway, that's what a comment is. You can also use comments as a troubleshooting tool in your code. So maybe you've written a bunch of code and you've got an error in there someplace, you got some kind of problem in your code, and you're trying to narrow it down, like where the problem is, but you might not want to delete a bunch of code, but you don't want it to get run or executed or whatever like that, because there might be a problem in there. So you can use a block comment or a multi-line comment to kind of comment out sections of your program so they don't get done or compiled, and then compile, and then you can use it as a troubleshooting tool to kind of narrow the code down to try to figure out what the problem is, if that makes sense. So that'll probably make more sense when you get to that point. But it can be a useful troubleshooting tool as well. All right, so those are comments, pretty easy to do. Programming languages also have special symbols that are designed to do certain things. So a special symbol could be like your arithmetic operators, and we'll talk more about those later, like plus, minus. Asterisk usually is used for multiplication. It can also be used for other things, like in C++, it could be used with pointers, which is a different concept we're not going to get into in this course, but kind of depends on how it's used, the context that it's used. Forward slash, it could be relational operators like greater than or equal to, less than or equal to. The exclamation point, equal, that means not equal to. So semicolon is another good example, the period. Those are all special symbols. You're also going to have reserve words or keywords. These are words, or basically words that have a predefined meaning in the language, right? They cannot be redefined, and they can't be used like for variable names or function names or something like that. So here's just a few examples, but there's a lot more than that. It can't be, some reserve words are things like data types like int, float, double, char. But it could be other words like void or return or const or something like that. Usually in your editor, in your text editor, when you type a reserve word, it's going to show you visually somehow that you just typed a reserve word. So it might change colors, like to blue or something, or it might change to bold. But usually you get some kind of visual feedback that that's a reserve word. All right, next thing. Identifiers. So you can probably guess what an identifier does, right? It identifies something, right? So identifiers can be things like variable names. They could be function names, names of constants, something like that. And so there are a few little rules that you have to remember for coming up with identifier names in C++. And basically they're these. So identifier names can consist of only letters, digits, and underscores. And they have to start with a letter or an underscore. They can have digits like numbers in them, but you can't start it with a number, with a digit. Also, C++ is case sensitive. There's a difference between uppercase and lowercase letters. So number here is not the same as lowercase number there. Right. And when you come up with identifier names, you're not allowed to use reserve words because those have a predefined meaning. And you can't use things like predefined identifiers like they mentioned here, cin and cout. Those are already designed to do something else. Okay. And they should be descriptive, right? Try to come up with descriptive variable names that describe what they're identifying. Here's some examples of some legal and illegal identifiers. So, and these are just bullet points, right? So first, conversion, pay rate, those are all valid, right? They only have letters, digits, and underscores, right? These are not valid, and so here they tell you why they're not valid. So employee salary, so why is that not valid there? Right, so you can't have any spaces in your variable names or anything like that. So if you have an identifier name that you want to have and it's like multiple words, so how do you do that? The standard that this book uses, and it's kind of become an industry standard as well, I believe, is this thing called camel case notation. And the way that camel case notation works is you use lowercase letters, but you capitalize the first letter of every word starting with the second word. So if you look at how they wrote pay rate right here, right, they've got a capital R on there. So they capitalize the first letter of every word starting with the second word. And so that's called camel case notation. And that's what I'll try to use in this course for variable names and function names. When it comes to constants, which we'll talk about what those are later, this book and I try to use all uppercase letters for constants. In the past, I used to use all lowercase letters for variables, and then I would separate words with underscores, but I've tried to get away from that, and I try to use this camel case notation now. But if you look, I might still have some old examples out there, example code out there, and so if you see any old examples with underscores in variable names, that's probably an old program. Other ones like hello with an exclamation point, that's not valid because you can't have any special symbols, right? So you can't have that. Over here they have a suggestion basically for, hey, if you instead of that you could go for this, and this would be valid. So like employee salary, notice how they did that, no spaces, and they did the camel case notation there. 1 plus 2. You can't have any special symbols like a plus. It's going to think you're trying to do addition right there. So you can't do that. But you could do this, 1 plus 2, but I don't know if that's describing. But anyway, second. So that's not valid because it can't start with a digit like that. But you could have a word like second like that. So does that make sense? So the main point of this is just to make sure that you remember the rules, right? You can only have letters, digits, underscores as to start with a letter or an underscore. All right. So those are identifiers. Here he just mentions a little bit about white space. Basically the gist of this is that, hey, you can, using certain standards of what we call white space makes your code a lot more readable. And so white space includes things like blank spaces, tabs, and new line characters, basically, blank lines in between amounts of code and stuff like that. So again, that can make things more readable. And so like in his code examples and when we do programs together, I'll try to make good use of white space to kind of make it more readable. Technically, you could left align all your code statements, all your source code, but it makes it hard to read. So I won't do that. All right, everybody cool so far? Next thing are data types. So last week, I think I've mentioned a few things about memory, right? And when we're talking about memory, we're talking about like main memory, RAM memory, the things in the little card things that you put on the motherboard, right? So when you want to store something, some data value inside of main memory, it could be, we have different types of data, right? It could be like a number. Even within numbers, we have different types of numbers, right? We have whole numbers that don't have a decimal portion. We have numbers, we call them floating point numbers, that have a decimal portion to them, right? Sometimes we have big numbers. Sometimes we're dealing with smaller numbers. We have characters, like single letters. We have strings, which is a computer science word for a collection of 0 or more characters. So all these things are stored inside the computer's memory in some way, but they in different ways, right? So we have different data types, basically. And there's some different general categories of data types. We have simple data types, structured data types, and this other thing called pointers. right? A simple data type is something, it's basically a memory location where this designed to store one thing, right? One number, one character, one string, whatever happens to me. String is kind of a different case. I might not initially include that. But anyway, a structured data type is a data type that has different parts. It has different components to it, or different parts, right? So a structured data type, in this course, towards the end of the semester, we'll talk about arrays, one-dimensional arrays and two-dimensional arrays, right? In Programming Fundamentals 2, we'll get into things like structures or records in C++. We call them structs. Then we'll talk about classes, right? And then if you take Programming Fundamentals 3, we get into more advanced structured data types. And in fact, Programming 3 is often called data structures. So, and of course, like that, we get into more advanced data structures like linked lists and stacks and queues and binary trees and you know, some really cool but more advanced stuff. Right, so anyway, structured data types have different parts. And so what is this other thing? What is a pointer? So pointers are a little bit different. Instead of actually storing a value, like a number or a character or something like that, instead, a pointer will store the memory location of where something else is stored, if that makes sense. So all these different places in memory have addresses, right? So a pointer is going to store the address of where something else is stored. It points to something else. So that's why they call it a pointer. And you can do all kinds of crazy and cool things in C++ with pointers. In fact, those more advanced data structures that I just mentioned, a lot of them use pointers in some way, like linked list and binary trees, and so that's how they work. All right. So here we're going to focus mainly today on the simple data types. So within the simple data type category, you kind of have some other smaller categories. Integral data types, floating point data types, and enumerated data types, right? So integral data types, I guess we don't have a separate slide on that. Integral data types are data types where the value can be stored as an integer. An integer means it's a whole number, no decimal place, okay? And so integral data types include these actual data types in C++. We've got chars or characters. There's short, int, and long. Those are designed to store integer numbers. We've got bool, which is like a true or a false. It's a Boolean. And then we have unsigned versions of char, short, int, and long. So basically the unsigned versions differ from the signed regular versions in that all the memory is reserved for positive values. So like an int, for example, half of the memory combinations of 1 to 0s are reserved for negative numbers, half are reserved for positive numbers. But with the unsigned version, you can only have positive numbers. So the unsigned int, you can store or represent a number that's twice as large as just an int, if that makes sense. But in this course, we'll be dealing mainly with things like characters, int, bool. Those are the main ones of the integral data types here. So how do these differ from one another? One big difference might be in how much memory gets reserved for them, right? So for example, an int on a lot of compilers in C++ might reserve like 4 bytes, okay? And we talked a little bit about bits and bytes, I believe, last week, but 4 bytes, there's 8 bits in a byte, right? So 4 bytes is talking about 32 bits, okay? And so basically, that's if you do 2 to the 32nd Yeah, to the 32nd power. That's basically the number of combinations, but like I mentioned, half of them are for the negative numbers and half for positive numbers. So, this is basically the range. So with an int, you can store or represent numbers from that range, from that negative number to this number here. Boolean, the Boolean data type, there's basically only two things you can store, true or false, right? And so you don't need much memory for that. So most compilers are just going to reserve like 1 byte. Character in C++, C++ uses the ASCII standard for characters. And we'll talk more about that probably in a little bit, but ASCII, there's 256 characters, so and so you have the standard ASCII character set, which are the positive numbers here, and then you have the extended ASCII character set, which I believe usually uses the negative ones. But if you look at the ASCII table, ASCII character set, see you next week, it's going to be focused on these positive ones. And there's an ASCII table in the back of your book in one of the appendices. And I also have some other versions as well. And you can just Google ASCII table or whatever and get it. All right. And then a long is going to reserve more memory, basically. All right. A lot of these things, at least the numbers, can be positive or negative. So valid values, if it's a negative number, you just put a negative sign in front of it. If it's positive, you don't have to put a plus, but you can. Don't use any commas in your numbers when you're in your programs. So that's not, you don't do that. That'll mess things up. So you just type the numbers, no commas. All right, a bool. I think I've said all these things already. Bool is a data type. Values are true or false. So you use the words true or false, right? But technically, I believe what it stores is a 0 or a 1. So 1 is for true, 0 is for false. Character is just a single character, and like I mentioned, it's in C++, it uses the ASCII character set. If you're talking about character values, you use single quotes. So make a mental note, characters, single quotes, okay? If it's a string, even if it's a 1-character string, double quotes. And yes, the space is actually in the ASCII character set. So here they talk about ASCII a little bit. I think I've said those things already. There's other ones as well, other character sets. Java uses something called Unicode. Unicode, actually, there's like 65,000 something different characters in the Unicode character set. There's one called EBCDIC, but C++ uses ASCII. All right, how about floating point data type? So a floating point number, a floating point value is basically just a number that has decimals in it. Even if that decimal portion is 0, something 0.0000 or whatever, if it's 0.0, it's considered a floating point number, right? And so these are all examples of floating point numbers over here, right? If you see it like this in C++, that means it's in scientific notation. So like 7.592400E1, that means 7.5924 times 10 to the first power. So basically, all these are the same number across the board. You see different notation and stuff. So as far as actual data types, in the floating point data type category, you have float and you have double, and I think there's long double as well. So basically the difference with most compilers is how much memory gets reserved for these things, and so they call it a double because it's twice as precise as a float, right? So at least in this course, we'll probably use doubles for most most of the time for floating point numbers. But I think there might be some compilers that actually these days that might use the same amount of memory for float and double. I'm not totally sure on that. So precision is basically talking about how many significant digits it's precise to, right? All right. So we've talked about data types, we've talked about identifier names, right, and reserve words, those types of things. So let's kind of combine some of those things and talk about variables. And then we'll get into assignment statements and some arithmetic expressions. Actually, I think I'm skipping ahead a little bit. I'll give you the short version first. Right. So a variable basically is a memory location that can store something, and that value can be changed later. So it's variable, it can be changed. But before you can use a variable, you have to declare it. Okay? So when you declare a variable, basically what that does is it reserves memory for it. So you have to specify the data type that determines like how much memory gets reserved for it and stuff like that. And then you put an identifier name. And so it's got to be a valid identifier name. And so it reserves memory for it, associates that identifier name with it, and so that you can access it later. So it's really easy to do. All you have to do is put the data type, space, and then the identifier name, and then a semicolon. And that declares it. So here's some examples: int, counter, semicolon, double, interest rate, semicolon, char, grade, semicolon, and so forth. Right? And then after that, you can assign a value to it. We'll come back to that. All right, so next thing to talk about are some arithmetic operators and arithmetic expressions. So we're going to do a little bit of math. So in C++, these are the main arithmetic operators that we usually have to work with. We have plus for addition, minus for subtraction. So these could also be used like to signify a positive or negative number. Asterisk is for multiplication. The forward slash is for division. And then there's this one that you may or may not have seen before, the percent sign. It doesn't do percent. It does something called modulus or mod. Right? So modulus gives you the remainder after you divide two numbers, basically. Okay? And in C++, you can only use modulus with integers. So in some other languages, it might work with floating point numbers, but not in C++. Okay. So here's something to point out, and we might look at some examples. Yeah. There's some examples in the book that I'll point out. They all work pretty much like you would expect them to work, except for maybe the division forward slash. Because in C++ and a lot of languages, there's a difference between integer division and floating point division. Right? So let me find some examples here real quick. Yeah, so like on page 43 of the 8th edition of the book here. Yeah, some basic examples. I would normally do this on the board, but since I'm recording this, I'll try to do it here. All right. So basically, if we did something like, let's do some simple ones, like, I don't know. And again, this is more about how does the computer do it. All right, so 2 plus 4, what is that? 8. I'm sorry, 2 plus 4 is 6. Sorry, my brain isn't working either. I don't know. 3 times 7. What's that? 21, all right? Cool. Subtraction 8 minus 3, 5, right? So how about well, we did multiplication. How about division? So how about this one? 5 divided by 2. Well, actually, let's do one that's even first. 6 divided by 2, right? So what is that? 3, right? That's easy. But then, yeah, what if we did something like 5 divided by 2? What's that? Right. So we know in our heads that that's 2.5, right? 2.5. But the way that the compiler is going to calculate that, it's going to do this as what we call integer division. If both numbers are integers, 5 and 2 are integers, they're whole numbers, it does what we call integer division, and it only returns the whole number part. And it doesn't round up or down or whatever, based on, what the decimal part would be. It just truncates the decimal part, basically. You only get the whole number part. So the result of 5 divided by 2, integer division, is going to be 2. Does that make sense? I'll try to give you an example of what this could be useful for here in a minute. But this is a whole number division. This is integer division, what we call integer division, okay? Now, if you were to do this, 5.0 divided by 2.0, those are not integers anymore. Those are floating point numbers. Even though, yes, you're looking at it and probably thinking, that's the same number, right? Those are the same numbers, but how they're stored in the computer's memory is different. Okay, so that's kind of the point of why we're doing this and why we're talking about it. So 5.0 divided by 2.0, those are floating point numbers, and it's going to do what we call floating point division. Right? So when it does floating point division, it's going to return the actual decimal answer. Right? So that is going to give you 2.5. Right? The result of that is 2.5. So, and you might be wondering, well, what if one of them is an integer and one of them is a floating point number? That's called a mixed expression. I think there's another slide for that here in a minute. But to give you the short preview answer, if you had something like this, it's going to look at that. The compiler doesn't like to have a mix where the integer and a floating point number. And so it's going to automatically convert the 5 to 5.0, and it's going to do floating point division on that. But here we'll see in a few minutes, it only does it at the point in time of when it reaches that situation. So if you have a longer expression with a lot more calculations in it and stuff like that, it's only going to do that conversion at the point in time when it reaches that. So anyway, let's do a few modulus ones, because see how that works. So here, the one they have in the book is this 34 mod 5. Okay, and again, it doesn't do percentage. Don't think it does that. So the percent sign, that does modulus, and so the modulus returns the remainder after you divide the two numbers. So remember back in elementary school when you're learning about division, but you don't know about decimals yet or fractions? And you write like 6 remainder 4, right? Remember that? That's what modulus gives you. It returns the remainder 4. It returns the 4 part, the remainder, okay? So the result of that, 34 mod 5, would be 4, right? Does that make sense? Sort of? And that's useful for certain things. This one might look a little weird at first. Let's do this one. 5 mod 3. Let's do that one first. So what is that? 2, right? So it's like, if you do the division, it's like 1 remainder 2, right? So again, it gives you the remainder part. So that gives you 2. But what if they were reversed? 3 mod 5. So what if the first number was smaller than the second number? What is that? The result of 3 mod 5 is actually 3. So the question again is, what's the remainder? How much do you have left over? So I know, here's how, this helps me a little bit. Right? So suppose you have 3 pennies, right, in your hand, right? So you've got 3 pennies. How many nickels do you have? Nickels worth 3 pennies, right? Yeah, it's worth 5 pennies, right? So how many nickels do you have? Well, you don't have enough for a nickel, but then the question is, how much is remaining, right? How much do you have left? Well, you still have your 3 pennies, right? So again, what's the remainder? I don't know if that helps any, but that helps me sometimes. So 3 remainder 5 is 3. So if the first number is smaller than the second number, like assuming they're positive, you get the first number back. Then they do have a note somewhere here in the book. Where is that? Where is that?
Can I take a picture of that?
Yeah, go ahead. I'm probably going to add a couple more to it. I wanted to mention about negative numbers with modulus. I don't think I'm going crazy. I know it was in an earlier edition of the book. Okay, that's messing with me. Yeah, here it is. Dang it. As soon as I do that, I find it. It's staring me right in the face. Gosh, I'm losing it. So, remind me to cut that part of the video out. So let's see, over on page 47. God, it's right there. Page 47, it says, you should be careful when evaluating the mod operator with negative integer operands. You might not get the answer you expect. And it has some examples here. So it gets a little bit different with when you throw in some negative numbers. So like here, he says like negative 34 mod 5. Right? Negative 34 mod 5. the answer to that, the result is -4, actually. Because, and he says, because in the division -34 divided by 5, the quotient is -6, and the remainder is -4. Okay. Similarly, in the expression 34 mod -5, 34 mod -5, the answer is, the result is 4. Because in the division 34 divided by -5, the quotient is -6, and the remainder is 4. All right. Also, -34 mod -5 is -4. Yeah, because in the division -34 divided by -5, the quotient is 6, and the remainder is -4. So, anyway, basically, it kind of looks like if the first number is negative, the remainder is going to be negative. So, on the quiz, I don't think I ask you to do modulus with negative numbers. But anyway, I always try to point that out. So, and again, that was over on page 47 of the 8th edition of this book. All right. And again, they have more examples in the book, so you should definitely read through the chapters. How about some mixed expressions? So those get a little bit more complicated. So let's look at a few of those. So like I mentioned earlier, a mixed expression is where you have a mix of integers and floating point numbers in there. And so the compiler doesn't like to have a mix like that. So what it's going to do is when it encounters a situation where you've got an integer and a floating point number, it's going to convert the integer into a floating point representation or floating point equivalent of that. Basically, it's going to change it to 0.0000 whatever, and it's going to use that value to do the calculation. So it's going to convert the int to a floating point number. But it only does it at the point in time at which it encounters it. So if you had a larger, well, let's just do this one. We'll do some and we'll talk about what happens. So if you have something like this, like that. So what happens there? And also your order of operations, if you have a larger expression, the order of operations is what you're used to in mathematics. So multiplication, division, and modulus actually are in a category, they're going to get done before addition and subtraction, and unless there's parentheses that group things. You always do innermost parentheses first, right? And if you have things on the same level, you do them in order from left to right. So how would you evaluate that? So, right, so the division is going to take place first, right? And so on that one, 3 divided by 2 is what? 1. Yeah. So again, the point of this is how is the computer going to think, basically? So 3 and 2 are both integers. So 3 divided by 2, integer division, gives you 1. And then it encounters this, 1 plus 5.5. So notice that it didn't convert the numbers and do floating point division because it didn't encounter a problem yet or a mix yet. So it only encounters it at this point. So now it's got an integer and a floating point number that's going to convert the 1 to 1.0 basically. So basically it kind of does this. And then it does that addition. So then you get 6.5. Like that. Does that make sense? Well, let's do a couple more. So how about this one? This one, and these are, I'm getting these from the book here. 15.6 divided by 2 plus 5. So what does that do? So on that one, again, we do the division first, right? Not because it's first in the order, but not because it's the first one that's in the expression, but because division takes place before addition, right? So there we have 15.6 divided by 2. Well, you've got a mix, right? So it's going to convert the 2 to 2.0. So basically you're looking at this like that. So it actually does floating point division on that. So you get 7.8 plus 5 like that. Yeah, and then it's got a mix, right? And then it's going to convert the 5 to 5.0 and add those two together. And so you get what, 12.8? Yeah. So you see how that works? And that's how the computer's going to calculate it. We'll do this one down here. How about this one? 4 times 3 plus 7 divided by 5 minus 25.5. Yeah. So what do you do first there? You do the division, right? No, multiplication. I didn't see that one. Yeah, so 4 times 3, right, is 12. So then you're looking at basically this if you want to simplify it, right? So then what comes next? The division, right? So you do division, 7 divided by 5, integer division, right? Both of those are integers. So that's just going to be 1. So you're looking at 12 plus 1 minus 25.5, like that. And then what's next?
Then you add them up.
Right, so then you've got addition and subtraction that are on the same level. So we're going to add. So 12 plus 1 is 13.
4, 31.
Right?
21.
So then you're looking at a mix. So it's only at this point that it converts to 13 to 13.0 and does the subtraction, and you get what, negative 12.5, you say? Does that make sense? Is that cool with everybody?
You're gonna do this with mods too, right?
What's that?
You're gonna do this with mod too, right?
You want to throw some mod in there?
I didn't say I'm going to, I was asking.
Okay. So yeah. Well, what if we even did the same one? You want and just change the division to modulus, or heck, we can. Modulus you have to be a little bit more careful with because you can't do it in C++ at least with floating point numbers. So what if this was mod and this was over here was also modulus? So how would that work? 4 mod 3 is 1. Right, so you're looking at this. Actually, again, maybe we should make it, let's switch them. So we said 4 mod 3 is 1. So you're looking at so what's next? Again, modulus is on the same level as multiplication and division. So you do the modulus next. 5 mod 7 is 5. Good. And then you're looking at that. And then 1 plus 5 is 6. And someone help me out with that. Is that minus 19.5? Okay. So you get that. Oh, it converts the 6 to 6.0, right? show that step. But.
So on which quiz are we gonna do this?
So this will be in the chapter 2 quiz. Yeah. Do you want to take some pictures? Or?
Oh, I did.
Okay. So, and again, part of the main point of that is just to talk about how the compiler does it. It's going to think. Right? So check this out. One question I often get, and some of you might be wondering the same thing, what's up with that integer division thing? Why in the world do we need that? When would we ever use that? Right? So one example that I give in a common programming assignment that you might see in a book like this is the making change problem, right? So basically the scenario is this: you go to pay for something, or maybe you're a cashier, right? And you have to give someone back some change, right? Well, we have different coins, and we'll just keep it to coins and stuff. We have different coins that are worth a certain amount, right? So a quarter, obviously, 25 cents. You got a dime worth 10, nickel 5, and pennies 1, right? But if you have to give someone back 21 cents, say you have to give someone back 21 cents, right? You're not going to take a quarter and like take some tin snips or something like that and cut off a little piece of the quarter and say, this is 21 cents worth of the quarter, right? You're dealing with whole numbers, right? You're only going to give whole coins back, if that makes sense. So suppose you had to do something like, let's see, suppose you had to give 93 cents back, right? So how would you do some calculations to figure out how many coins and how you're what to give back and stuff, right? So you might start with, we'll just keep it, we don't have to include 50-cent pieces unless you want to. Do you want to include 50-cent pieces? Do people ever give those in change? And I've got a collection of them from when I was a kid. I always thought they were cool, but anyway, we'll just stick with quarters, right? So how are you going to know how many quarters to give back? Well, you can do integer division because that's what you want, the whole number part, right? So 93, integer division 25, right? So what does that come out to be? Right? Whole number part, right? So probably 3, right? So you're going to give 3 quarters back, right? That's how many quarters. But then you need to give back some more change, right? So how much do you have left over? We've got modulus for that, right? So then we could do 93 mod 25. And what does that come out to be? 18. Is that right? 18? Right? So we have 18 cents left, that we need to give back some change, right? So that's how much we have left. And then then we can keep going with that, right? So the next coin down is the dime, right? So 18 integer division 10. So how many dimes do we give back? So that's 1, right? So we need to give 1 dime back. And then how much do we have left over? Well, 18 mod 10, right? So what does that come out to be? 8, right? Good. And so then you keep going with it, right? 8 divided by 5, integer division. How many nickels? 1, right? And again, modulus. 8 mod 5. That was a little easier, right? 3. And then obviously 3 divided by 1, because we're talking about pennies, 3, right? And then if you wanted to, you could do 3 mod 1. anything mod 1 is just going to be 0, right? So there you go. So I need to give back and change 93 cents. I need to give back 3/4, 1 dime, and 1 nickel, and 3 pennies. Right? So hopefully that kind of shows a scenario where you do want to do integer division. You know, you only want the whole number part in some situations. All right, let's get back to where we were, unless anybody has any other thoughts or questions. All right. And if you have parentheses, again, you evaluate innermost parentheses first, right? Here they're just talking about the things that we just talked about. All right, so that type conversion thing that we just talked about, when you have a mix expression and it converts the integer to floating point number automatically, there's a term for that. And it's called type coercion or implicit type coercion. That's when the compiler automatically converts one data type to another. Okay, that's when the computer or compiler does it. Okay, sometimes you as a programmer might want to convert from one data type to another, assuming that it's a legal thing to do for the two data types you're dealing with. And when you do it as a programmer, that's called typecasting. Okay? Typecasting is when you as a programmer explicitly write the command and the instructions to convert from one data type to another. And there's different ways to do it. This is like the newer way, standardized way to do it. You say static cast, and then inside of angle brackets, the data type that you want to convert into, and then inside of parentheses, what you're going to convert. And so it could be a variable, it could be like a number, it could be an arithmetic expression that it gets evaluated first and then converted. And we have some examples here to look at. A lot of times I'll just kind of do it the old C way, and I'll just put the data type that I'm converting into in parentheses, and you can do it that way. There's a shorter way, but this is how the book shows it. So here's a whole bunch of examples. Let's try to go through them somewhat quickly, because there's only one slide here. Seems like they might have more in the book. So anyway, what if you did this? What if you did static cast int and then parentheses 7.9? So you're going to convert this floating point number to an integer. So when you do that, it doesn't round up or down or whatever like that. It basically just truncates off the decimal part, and it only gives you the whole number part. So when you convert a floating point number to an integer, there's a strong potential there to lose, the decimal value, and so you're going to lose it, right? So 7.9 is an int, is just 7. Here, static cast int 3.3 is just 3. Static cast double 25. You're not going to lose any information there, but it's going to change how it's stored in memory to 25.0. Actually, it's 25.0000000 probably. If you have a larger expression inside the parentheses, it's going to do what's inside the parentheses first. So static cast double 5 plus 3, it does the 5 plus 3 first. So that's 8, and then it converts the 8 to 8.0. But if that's not inside the parentheses, this one's different, right? So static cast double 15 and then divided by 2, it's going to convert the 15 to 15.0 first, and then divided by 2. It's going to automatically convert the 2 to 2.0 and do floating point division, because it's a mixed expression at that point. But if you did this is different. Static cast double 15 divided by 2 is inside the parentheses. It does the division first here, and that's integer division, which is just 7, and it converts that to 7.0. So it's all, there's a difference. You have to be aware of that. This one's larger, this one's longer, so I think they're saying imagine this is all on one line, one statement. So static cast int 7.8 plus static cast double 15 divided by 2, like that. So it's going to do this first, right? So it converts the 15 to 15 .0 and then divides that by 2. So that gives you 7.5. And then you're looking at 7.8 plus 7.5 like over here. And so it adds those and you get 15.3. And then it converts that 15.3 to an int. So it just drops off the 0.3. This is similar but different because it's doing the integer division first. So you end up getting a 14 on that. Does that make sense? And so you can convert ints to doubles, doubles to ints. You can usually do something as well like convert int to a character or a character to an int because it's storing an integer number anyway. But you wouldn't be able to do something that's more different like probably like convert maybe a string to a double or something weird like that. So what is a string? So a string is a computer sciencey word for a collection of 0 or more characters. Okay. Strings, when we're talking about string values or string literals, sometimes we'll call them, where we put those inside of double quotes. So if you see double quotes, it's talking about string. Single quotes, it's talking about characters. Strings can be empty. We call an empty string a null string. Strings also have positions to the different characters that you can usually identify to specify which character you're talking about. So that's what they're talking about there, the index of the character. And they have links. We'll talk more about strings later on in the semester. All right, so moving on. We've talked about variables a little bit. How about this other thing called a constant? So if a variable is something that can change, what do you think a constant is? Something that can't change, right? And so a constant represents something you want to store in memory and give a name to, but you don't want it to change. It's not going to change throughout the program. And if you try to change it later on in the program, you'll get an error. Right? So here we call these named constants. And the way that you declare and assign a named constant is like this. You put the reserve word const, and then the data type, things like int, double, char, or whatever it happens to be. And then the identifier name has to be a valid identifier name. I usually use the same convention as the book does. I use all uppercase letters for constants, and I separate words with underscores. That's how they do their constants, but they use camel case for the variables. And then, because it's a constant, you also have to assign an initial value to it when you declare it. So you say equal to whatever, semicolon. So here's some examples. Const double conversion is equal to 2.54, semicolon. So that's basically like probably the number of centimeters in an inch, right? Const int, number of students is equal to 20. Const char blank is equal to a single quote. So, but that's basically how you do that. So that's how you do a constant. Like I said, a variable is a memory location whose value can change. So, and you have to declare them. So here's some more examples of declaring variables. Double, a Mountain Dew, int, counter, char, ch, int. Check this one out. So if you have multiple variables of the same data type and you want to declare them in the same line, you can do that like this, int x comma y, so you can have a list. So you put commas in between them, so you can declare a whole bunch in one line. String space name, right? So it reserves memory for a string. You might notice in the slide, they didn't show string as a different color. That's basically, in C++, the string data type is not a true built-in data type. It was something that was added later to the language, the string class. That's why you might see that. So how do you, after you declare a variable, how do you put a value in there? Well, this kind of combines some of what we just talked about with arithmetic expressions with data types and variables. So you declare the variable first, and then you can assign a value. You can actually assign an initial value when you declare it as well. So with an assignment statement, you just say whatever variable it is equal to, and then some expression. So here's some examples. And again, here they have kind of a walkthrough of what gets stored where. And they have more examples in the book as well. But suppose you had these variables declared. Num1 and num2 are integers. Sale is a double. First is a character. str is a string. Well, again, you can think of if it helps, you can kind of think of a variable as like a container that's going to store something, right? You can put something in that container. And the name is just like the label for it, right? So num1 is equal to 4. It stores the number 4 into the memory location that's reserved. That's called num1. I don't know if they have. I don't show that there. How about this one? Num2 is equal to 4 times 5 minus 11. So it evaluates that expression. 20 minus 11, so you get 9. So it stores a 9 in num2. Sale is equal to 0.02 times 1,000, so it'll store that. D, first is equal to the character D. So it stores the character D into first and actually stores the ASCII value of D, which is, 69? Something like that. Capital A starts at 65. Right? STR is equal to, it is a sunny day. Notice they put that in double quotes. All right. You can actually do this if you want to. This looks kind of weird. What will change here? X and Y are going to be changing, but not Z technically. It'll take whatever is stored into Z and store that into Y. And then as a result, whatever is in Y, it'll store that into X. But anyway. So this shows that, hey, you can declare a variable and then initialize it in the same statement. So int first is equal to 13. So it declares first, reserves the memory, sticks 13 in there. There's some other similar examples. In C++, when you declare a variable, it does not automatically assign an initial value to it unless your particular compiler happens to do that, right? You're not guaranteed that it's going to do it. And in fact, usually you might just have some garbage value in there. Now I've noticed that the newer versions of the dev C++ compiler, like when you declare an integer, for example, I believe it automatically puts a 0 in there, but not all versions of the compiler do that. All right, next thing, how about some input? So if you want to get input and you want to input some value from the keyboard, for example, and store it inside of a variable, you can do it with an input statement. And in C++, we have this thing called cin that allows us to do that. Console input is probably what it stands for, I'm not sure. And the way that it works is you say cin and then 2 greater than signs. So when we call this the extraction operator, we're going to extract some input from the input stream and then a variable name. And this has to be a variable that's been declared already. Okay? So here's an example. Assuming that you had a variable named Miles, you can say cin extraction operator Miles, and at that point of your program is going to stop, and it's going to, on the output screen, it's going to have a cursor there, and it's going to be waiting for you to type something in. Okay? And whatever you type there, it's going to store it into that memory location, that Miles variable. You can actually chain, if you have multiple variables that you want to input with the same CN statement, you can kind of chain them together like this. CN, feet, and inches. So you're going to type, the idea is that you type a number, and the first number gets stored into feet, and the second number you type gets stored into inches. Right? In Chapter 3 gets a lot more detailed about what happens with input and output in different situations. Okay, depending on, so what if feet was declared as an integer and your user screwed up and typed in the letter A and not a number? What happens? So that's one thing that they talk about in Chapter 3. Let's see. I'm going to try to keep going here. Increment and decrement operators. So basically what these do, the increment operators will add 1 to a variable and assign it back to itself. So if you want to increment a variable by 1, you can use the increment. Decrement, you can probably guess, subtracts 1 from it. Right? So if you're wondering what's the deal with this, we've got 2 versions of it, pre-increment and post-increment. Right? The difference, if you just use it by itself, you're not going to see really a difference. But if you use it in a larger expression, there is technically a difference. Pre-increment increments the variable first, and then uses that new incremented value in the rest of the expression. Post-increment will evaluate the expression first, and then after it's done, then it'll increment the variable. So look down here. So if you did this, so if you had a variable like x, and you said x is equal to 5, and then you said, assuming these are both integers, y is equal to plus plus x, what's going to be stored into y? With pre-increment, it's going to increment first. So it's going to add 1 to x, which is make it 6, right? 5 plus 1 is 6. And then it's going to use that value, and so it'll assign 6 to y. So x is going to end up as 6 in both of these, but y is different. So here, y is 6. But over here in post-increment, x starts off at 5, and if you say y is equal to x plus plus, it's going to assign x first. So it'll assign 5 to y, and then it will increment. It increments after post-increment. So then x becomes 6, but y is 5. Does that make sense? So I hardly ever use it like this. Most of the time you're just going to see it as just by itself, like x plus plus, by itself. But technically there is a difference. And pre and decrement work the same way. All right, so let's talk about output real quick, an intro to output. So if CN is used for input, what do you think is used for output? Cout, right? And that's how we say that. It's not count or something like that. I say cout. So cout, and then you use 2 less than signs, which we call the insertion operator. You're going to insert something onto the output stream. And so you say cout and then insertion operator, and if what's next is inside of double quotes or single quotes, assuming it's a character, it's going to output that actual whatever's in quotes. Okay, but if it's a number, it's going to output the number. If it's a arithmetic expression, assuming it's not inside of quotes, it's going to evaluate the expression and then output the result. If it's a variable name, it's going to output what's stored in the variable. And then you also have this thing called indel that will output. Indel means end line, not the indel, not an end one. Indel means end of line, so it goes down the next line. So here's some examples, and over here is what ends up getting output. So if you said cout 29 divided by 4, that's integer division, right? So it outputs the result of that, which is 7. Cout hello there, that's inside of double quotes. So it outputs hello there. If you just do cout 12, it just outputs 12. If you output, do cout 4 plus 7 inside of double quotes, it outputs what's inside of the quotes. So it outputs 4 plus 7. But if you do this, cout 4 plus 7, not inside of quotes, it evaluates that and outputs 11. Here it outputs an A. But what if you'd just done cout A with no quotes? It would assume, it would think that A was a variable name. And if you have a variable named A, it would output what's stored in A. But if you don't have a variable named A, you'd get an error on that. How about this? You can actually chain different output together. So cout 4 plus 7 equal. And if you want spaces to be output as well, you need to put them inside the quotes. So it outputs 4 plus 7 equals space. And then the next thing is 4 plus 7. So it's going to output the result of that. 4 plus 7, which is 11. 2 plus 3 times 5. So it evaluates that. So 15 plus 2 is 17. And how about this one? This one's a little bit different, right? Hello there. But it's got this backslash n in there. So the backslash n is what we call the new line character. It's basically the same thing as the indel. It's going to go down to the next line, but the backslash n is a character. So it's got to be used like inside of a string or as a character value. But that'll make it go down the next line. So there's some other escape sequences, and so that's what this is. The backslash n is the new line character. Backslash t is the tab. It'll go over the next tab style. It's usually like 5 characters over. Backslash b actually is a backspace. So if you output a backslash b, it's actually going to go back one on your output screen, and then if you output something else after that, it'll write over what you just backspaced over. Backslash r moves to the beginning of the current line, so it basically rewinds to the beginning of the current line. So if you output some more, it'll write over what you had output before. If you actually want to output a backslash, you put 2 backslashes, and if you want to output a single or double quote, you have to use the escape sequence for that. So backslash single or double quote. If that makes sense. So those are some commonly used escape sequences. All right, bear with me. Stay with me here. We're close to. There's a lot in this chapter, so. Preprocessor directives. So in order to use certain things like cin and cout, or maybe some built-in functions or whatever it happens to be, you might have to include the correct header file that actually contains the code that makes those things work. And the way that you do that in C++ is you put a number sign, or these days you guys probably call it the hashtag. And then, so number include, and then inside of angle brackets, the header file that you need to include. And so, for example, to use cin and cout, you have to have this line at the top of your program. Number include IO stream, input output stream. That contains all the code that makes cin and cout work. And so there's a whole bunch of those, and you kind of have to get the hang of which ones to include, but we'll talk about those as we go. There's also this line, using namespace std or standard. And I'll talk more about this, but basically the gist of this is inside of the IO stream header file, there's a whole bunch of stuff in there, but there's like one section called standard or std. It's kind of that label, and that's where all the cin and cout stuff is located. And by putting this line here, using namespace standard, I can just type cin and cout. If I didn't do that, I'd have to, anytime I use cin and cout, I'd have to type std : cin or std : cout, and that gets old pretty quickly. So by having this line, that spares me from having to do that. So we'll do that in our programs. String, if you want to use the string data type or some of the built-in functions that strings support, you can include the string header file. Here is the main function. I've already kind of talked about that, so I'm going to plow through this. Talk some about source code, and yeah. So here they have a little example here, and let's keep going. But let's try to do our own example. So let's see if we have time to at least get started on that. So it takes oh, I always forget these things. Let me talk about them real quick. Right? The compound operators, or sometimes I call them the combo operators. We talked about pre-increment or the increment and decrement operators where you want to add or subtract 1. But what if you want to add or subtract or multiply or divide or mod or whatever, something other than 1, like 5 or something like that? Is there a shortcut way of writing that? Instead of typing something like x is equal to x plus 5, yes, you could type instead x plus equal 5. So it's just a shorter way of writing those, which if it's just a variable, it's not a big deal to type it all out. But like if you're dealing with like a structure or something like that that's longer, these things come in handy. All right, and there's a quick review. All right, so that's that. Let's do an example real quick. Let's see if we have time to do that. So I'm going to stop this.